Good morning to all of you. Welcome to Dr. CSR Academy. Myself, G. Ramesh, Faculty of Chemistry, Gold Medalist in MSc Chemistry with 20 years of teaching experience. Today, regarding to our program, just regarding to JEE, there are two kinds of patterns, JEE Main and JEE Advanced. So we have JEE Main exam, which is there to qualify and to get the seat in NITs, all National Institute of Technologies. So in JEE Main, we have 25 questions chemistry, which will be there 100 marks into 4, that will be for 100 marks. You know what? Out of which, out of this 100 marks, you know that chemistry with is there 3 branches we have organic chemistry, we have inorganic chemistry, and we have physical chemistry. So almost nearly equal priority are there. Likewise, it's 9 questions. It will be 8 questions, and it will be 8 questions. Total, it will be 25 questions. So a little bit organic chemistry has more demand. Last couple of years, almost 4-5 chapters were deleted by the CBSE board as well as the NTA program. Because of that, now it became organic, became the most important part. All right. And in the case of this one, the most important pattern, most important points that we have to observe is the standard of questions. So here I will explain kind of some standard of questions, and I explains about the shortcuts in chemistry. Shortcuts in chemistry also will go through based on the topic. For example, regarding to organic chemistry, students will feel seems to be a little easier, but in fact most of the students are stuck up with the organic chemistry, and doing the problems of organic chemistry, many of the students are doing the mistakes because based on the simple errors, especially bond polarization effects like called inductive effects, mesomeric effects, and hyperconjugation. So if a student gets more and more deeper into the principles, they can perfectly answer the organic chemistry well. And most of the inorganic chemistry questions are linked with chemical bonding, because molecules like ammonia or PCl5, PCl3, all are little bit purely based on the hybridization. If a student good at hybridization and how to develop its geometry, how to identify its shape of the molecule, like kind of a type, especially about the type, then student get a good score in the case of inorganic chemistry. Physical is linked with each chapter wise, because it's not linked thing, because atomic structure is one kind, chemical kinetics is another kind, electrochemistry is another kind. Each of it has own importance. But organic and inorganic both are interlinked. So in this session, in today's session, let's have a look on concept of hybridization, which explains the geometry and types of the molecules especially. Observe this one. We can go through this one, concept of hybridization. which is also called hybridization concept. Hybridization concept, which is called hybridization concept. It is mainly explains about the geometry of molecules, because geometry is purely based on the hybridization, which will be linked with type of the molecules and which will be linked with the shape of the molecule. Most of the students have a confusion that the geometry and shape they feel it is same. Not actually. Geometry is it is linked with, it is including lone pair. This is including lone pair, and shape is excluding lone pair. It is excluding lone pair. Say for example, very simplest and popular molecule like ammonia, if you take NH3, ammonia is actually hybridization sp3. Students knows that it is a automatically tetrahedral molecule. That means anyone can write this kind of way. It has a lone pair also. That means if you observe this one entire, it will be like a tetrahedral geometry. This is ammonia, tetrahedral is geometry. So geometry is tetrahedral. While if you see the particular shape of the molecule of ammonia, it looks this way. This is just pyramidal one, because you don't observe these lone pairs. Its lone pair is we can't observe because it is invisible. It's not an atom. Therefore, it is like a pyramidal. So pyramidal is the shape one. Shape is pyramidal, while geometry is tetrahedral. So tetrahedral is geometry. It is based on, this is AB3E. Any AB3E type. Important thing is about the type. Type is AB3E. Based on the type only we can mention whether it is tetrahedral or whether it is pyramidal. So as the ammonia is the pyramidal shape because of AB3E. So here I'm going to give you a best shortcut to develop hybridization, immediately type and then shape of the molecule. In fact, if a student is good, you can understand, you can develop even the bond angle also. Say for example, NH3, as the hybridization is sp3, we can expect bond angle is 109 degrees 78, 109 degrees 28 minutes. 109 degrees 28 minutes. It is the expected thing. But actual bond angle is 107. Why the 107? Why not something else? So here is this is 107. The reason is it has a lone pair. Lone pair repulsion is there on the bond pair. So which is called LP-BP repulsions. This LP-BP repulsions makes the bond angle from 109 degrees 28 minutes to 107 degrees. So observation is more needed on the kind of type, which is linked with hybridization and of course in combination with VSEPR theory also. So our cumulative point is about VSEPR and hybridization. The point is about hybridization and VSEPR. Observe carefully. Here what I am explaining to go through is, this is the point is about hybridization plus VSEPR theory. And if a student is good at chemistry, even though they will miss some of the points, even especially about the bond angles kind of. If you listen it carefully, you can do it very simple within a fraction of seconds. I usually say within 5 seconds. Just 5 seconds, how can you identify a hybridization, geometry, type, shape and bond angle? Minimum 5 characteristics you can develop. So here I am going to give you shortcut to find these are all the characteristics. First thing is hybridization. Second thing is geometry. You can find geometry. Third point it is that you can identify the type. If you know the type, then only you can identify shape of the molecule. And finally you can identify bond angle also. So all these 5 characteristics you can develop within 5 seconds. What my observations. That kind of most important shortcut I am going to explain in this session. Let's carefully observe. Simplest, I will go through example 1. Suppose H2O molecule is that water molecule. See, water molecule. You know what? H2O, CH4, ammonia, all three belongs to sp3 hybridization only. But there is a difference. H2O belongs to AB2 E2 type. CH4 belongs to AB4 type, while NH3 belongs to AB3 E type. Now, you should understand what is the difference among them, how to develop whether it is AB3E or AB2E2 or AB4. For this, you can follow the shortcut. The shortcut is this one, that is the number of hybrid orbitals. Number of hybrid orbitals, that is equal to half into Z plus M. Z plus M. This is the best way to identify these characteristics. Hope you are following. Let us observe. Number of hybrid orbitals is equal to half into Z plus M. And you should write what is called Z, where Z is the group number of central atom. Group number of central atom. Group number of central atom. While M is number of monovalent atoms. Number of monovalent atoms. Okay. And you will get a doubt what are called monovalent atoms. What atoms we have to consider here? Only you should take hydrogens and halogens. So here you have to take hydrogens and halogens only. What are called halogens? It might be fluorine, chlorine, bromine, iodine. They are called halogens. So you can take hydrogens and halogens. Only this is enough to mention the hybridization and to find the geometry. Suppose if this value, that means number of hybrid orbitals, if this value, number of hybrid orbitals, if it is there too, then hybridization is automatically sp, and definitely the geometry will be linear, because sp hybridized molecules all are linear only. That will be linear. So this kind of way you need a simple tabular form. That tabular form can give you the proper idea. Especially just it is about 2, 3. 3 is there sp2. Trigonal planar. Trigonal planar. It is a trigonal planar geometry. Trigonal planar. And if it is there 4, that is sp3 tetrahedral. sp3 which will be tetrahedral. Hope it is visible. And okay. And if it is there 5, sp3d, trigonal bipyramidal, which is called TBP, trigonal bipyramidal. And at last we can have 6 octahedral also. So what I mean to say, this tabular form is the important matters. Better you can write about 6th one also. Okay, I'm taking the next slide. So if it is 2, that is sp hybridized, and that is linear one, and this is 3, that is sp2 trigonal planar, sp2 that is trigonal planar. In fact, you should have an idea on this one. Trigonal planar means you can take like this, central atom is the A here, and 3 are the bonded atoms, which looks like trigonal planar is this one. This is called AB3 type, and it's there like AB2 type. Here is the bonded atom, here is the bonded, which will be linear. This is 180 degrees bond angle. And while in the case of trigonal planar, that is 120 degrees is the bond angle. And if it is therefore, that is sp3, which is tetrahedral, and you can write this way, AB4 molecule, which will be like this way, tetrahedral is like this way, AB4 is this way. You can draw the shape also based on this one. You can see this is the shape of the molecule. You can observe this way it will be tetrahedral, and this is trigonal planar, and this is linear. Same like that if you go with the next one. So here you can take that 5 is there sp3d, TBP you can call it as trigonal bipyramidal. Trigonal bipyramidal means A is the central atom, 3 on the same plane, and 1 top, 1 down. Trigonal bipyramidal. That means shape it looks like this way. This is trigonal planar on the same plane. It is top and it is down. All are called B. The atoms of the B are like this way. So this is trigonal bipyramidal, which is called TBP. Yeah, you can understand the bond angles are here. It is there 120 degrees are there, 90 degrees are there, and 180 degrees are there. There are 3 bond angles are possible, but here this is 109 degrees 28 minutes because tetrahedral. And you should observe the bond angles about the molecules. These are the reference molecules, means without any deviations. Why the deviation word I used? If central atom has a lone pair, then geometry will be converted into shape. That will be different. If no lone pair on central atom, geometry and shape are similar. So you should understand this point that if no lone pair on central atom, and you should remember this is the most crucial point, then here that geometry is equal to shape. Geometry equal to shape. They are same. That means if no lone pair on central atom, it's not about the lone pairs on the bonded atom. It is about the lone pair on central atom. If no lone pair on central atom, then geometry and shape are similar. Like methane, like PCl5. Methane is tetrahedral because no lone pair. And PCl5, trigonal bipyramidal. 3 on the same plane, 1 top and 1 down, like this. And this is the sp3. Here the example also PCl5 you can make it. And suppose here it is there 6, then it is sp3. This is sp3d. Here is sp3d. Now this is sp3d2. sp3d2 it is octahedral. sp3d2 is octahedral. You know the octahedral is like this. Central atom is A here, 4 on the same plane, 4b on the same plane, which will be like this way, and 1 top, 1 down. These are on the same plane. This is a B, this is B. These are called axial. It is called as an axial bond. It is also axial. This is called equatorial bond. There are 4 equatorial and 2 axial bonds are there. That means the top and down they are what we call axial bonds, and the remaining things what we can say that they are called equatorial bonds. Right? This is octahedral without any lone pair. And anybody can expect the bond angle will be? Yes, bond angle is here is because 360 shared by 4. Therefore, here is the bond angle is 90 degrees. From here to here also 90 degrees. So you can expect only 90 degrees are the better bond angles. So it is there having 90 degrees bond angles. 90 degrees. Only 90 degrees. And finally, this is 180. It can have 180 degrees also. We have only 2 particular bond angles in this sp3d2. And the last one it is there sp3d3. You can say that 7th one sp3d3, which is called pentagonal bipyramidal, PBP, pentagonal bipyramidal. That means there is a pentagon and it is having 1 pyramidal top and 1 pyramidal down. Simply here I am indicating central atom is there. A is the central atom. 1, 2, 3, 4, 5. 5 on the same plane. Like this, 5 on the same plane. 1 top, 1 down. Which is there. It is a pentagon. It is a pentagonal and bipyramidal. 1 pyramidal from the top and this one. Suppose like this way, it can have 5 on the same plane. And there is a 1 atom on the top. So it will be a pentagonal pyramid. And down also there is a pentagonal pyramid, which will be called a pentagonal bipyramidal one. And this is. And anybody can expect as 5 are there oriented in 360 degrees. So you can have 72 degrees each is the bond angle. Therefore, the bond angles are 72 degrees and of course 90 degrees and of course 180 degrees. Because you know what? From down and the top, that is there 180 degrees. From this to this, it is 90. The important question here is, how many 90 degrees bond angles are there? From this to any of the 5 atoms. That means 5 90 degrees bond angles are there from this, and 5 more 90 degrees bond angles are there from the down atom. There are 10 bond angles of 90 degrees. 5 from top atom and 5 from down atom. That's why most important bond angle is 90 degrees in this case. So we have these 7 cases as per the hybridization and VSEPR theory combination. Now interestingly, we will go through the molecules. You take any of the molecules. Suppose if you are going through PCl5, example 1 I am going through PCl5. Simply you can apply half into Z plus M. Group number of phosphorus is 5 plus 5 monovalent are there. 5 plus 5, 10, 10 by 2, 5. 5 immediately you can say sp3d. I told you about 5 seconds. I am reminding. How to do hybridization for PCl5 in less than 5 seconds? Number 1, phosphorus group number is 5 because nitrogen, phosphorus, arsenic, antimony, bismuth. They are fifth group. So you should have basic idea on the group number. Suppose third group, fourth group, fifth group, sixth group, and seventh group. You should have this basic idea. Students have already basic idea on the periodic table. Third group also got group 13, that is the boron family. Boron, aluminum, gallium. Indium, thallium also there, but at least first three you can remember. Fourth group, carbon, silicon, germanium. Fifth group, nitrogen, phosphorus, arsenic. Sixth group, oxygen, sulfur, selenium. Seventh group, fluorine, chlorine, bromine. Sometimes iodine is required. That's why iodine is required. Oxygen, sulfur, selenium, tellurium. Nitrogen, phosphorus, arsenic, antimony, which is Sb. Carbon, silicon, germanium, tin, Sn. Boron, aluminum, gallium, indium. At least this you should have the idea to say the group number of central atom. Alright. Now, based on that, phosphorus, already you can see group number is 5. So, there is a 5 and halogens are 5. I told you M is called number of monovalent atoms. So, how many monovalent atoms are? 5. Because monovalent includes only hydrogens and halogens. Therefore, 5 plus 5, 10. Immediately you are getting 5. Interesting thing is, you know what? Immediately you should draw this shape. I mean, you have to say, you have to draw trigonal bipyramidal. TBP. Trigonal, that means 3 on the same plane, 1 top, 1 down. It is the axial, it is the also axial. So this is called trigonal bipyramidal. As already bond pairs are 5, atoms also 5, there is no lone pair. Therefore, you can keep all the atoms are chlorine. This is the way 3, 4 and 5. Simply no lone pair on central atom, no LP on central atom. I already given a hint that if there is no lone pair on the central atom, then definitely its geometry and shape will be same only. Therefore, it's first of all, hybridization is sp3d. You have got hybridization sp3d. You have got geometry, which is a trigonal bipyramidal. You can say that type is AB5. That means there is no lone pair. If any lone pair is there, we will call it as E, symbol E, we will call it. Suppose AB5E, AB4E, AB3E2, like this way, that format. And this is AB5. No lone pair on central atom. I already given a hint to all of you remembered. That is geometry and shape are similar. Therefore, shape also same. Shape also same, that is trigonal bipyramidal. And you can say the bond angle also. Interesting thing about the bond angle also, you can develop all these characteristics will take just fraction of seconds. Not about PCl5, any molecule, kind of thionyl chloride or SOCl2, SO2, SO3, no limitations. We are here to explain unlimited way, not to a fixed things. Suppose like this, bond angles here is that it is 120 degrees and this is 90 degrees and this is 180. You have 120 degrees is the mostly, 120 degrees are there, and you have about 90 degrees, you have about 180 degrees. That you can understand because it's a simple molecule. Let's go for the next molecule is any example, no particular limitations. I am going to explain CH4, which is called methane, CH4 methane, related with ammonia and related with H2O. I want a comparison. I will explain the comparison. So you know what? Half into carbon group number is 4 plus 4 monovalent. 4 plus 4, 8 by 2, 4. That means you are getting the 4. Here you are getting 4. 4 it is nothing but immediately hybridization is sp3. Coming to this one. Nitrogen group number is 5. Nitrogen group number is 5. Plus monovalent are 3. 5 plus 3, 8. 8 by 2, 4. 4 is sp3. It is also sp3. It is also sp3. This is also sp3 because 6 plus 2 by 2. 8 by 2, 4, sp3. I am comparing all these three are having same hybridization. Not one molecule. 3 molecules taking within 3 also, we can say within seconds only. Not only hybridization, we can go for type. What is the type of the molecule? So, sp3 means tetrahedral. Geometry is tetrahedral. And already 4 bonds are there. Type is AB4. But here is 3 bonds only are there. Bond pairs are 3, but 1 lone pair. So, therefore, AB3E. AB3E. While this is same has 4 total hybrid orbitals, but 2 are only utilizing, therefore 2 lone pairs are there, which is called AB to E2. It is AB to E2. Here is the difference matters. AB4 tetrahedral without any lone pair, and AB3E it has one lone pair. AB to E2 it has 2 lone pairs. Obviously, there will be a change in geometry. Say, here is the geometry and shape, both are same because no lone pair. Therefore, it is tetrahedral. You can say, you can use a TD also, tetrahedral. AB3 geometry I am asking, geometry same tetrahedral, geometry same tetrahedral. Because all are sp3, therefore all geometry is same. But already there is a type, so we can have the shape of the molecules. So shape will be tetrahedral only because no lone pair. Therefore, its shape also tetrahedral only. Coming to this one, it is ammonia. I told you already it is a pyramidal one because we have 3 atoms only on the down. One is actually a lone pair. It is invisible. You feel that it is invisible. And you remember, including lone pair is called geometry. If you exclude the lone pair, which is called pyramidal, which is called the shape. Therefore, ammonia molecule is pyramidal. Ammonia is pyramidal. While coming to this H2O, a fantastic molecule, oxygen is at the center and only 2 atoms are there. So it can be visible like bent. One is the lone pair which is invisible. Another is also lone pair which is invisible. So visibility thing is there, central atom and 2 bonded atoms. So which is called a bent shape or a V-shaped molecule. Therefore, this is bent or V-shaped. This is bent or V-shaped. Bent or V-shaped molecule. And interestingly, you can say about the bond angle also. My point, I told you, you can develop hybridization, geometry, type, shape, bond angle. 5 characteristics we are developing. Now, here is no deviation. B means no lone pair. Therefore, bond angle as per the reference 109 degrees, 28 minutes. While coming to ammonia, there is a one point called lone pair. I told you, this is ammonia and lone pair is there. That lone pair put pressure on the bond pairs. That lone pair put pressure on this bond pair, hydrogen. Because of that, actually is 109 degrees, 28 minutes is expected. But thing is, due to lone pair repulsion with the bond pair, slightly, not much, very slightly bond angle is got decreased because of only one lone pair is that. Here only the point is lone pair bond pair repulsion. So the dominating factor is LPBP repulsions. Due to LPBP repulsions, 109 degrees 28 minutes slightly decreases to 107. So you can mention that it is exactly 107 degrees. Now coming to the H2O molecule, it has 2 lone pairs. That lone pair, first of all, it can have a repulsion with another lone pair. The dominating factor is LP-LP repulsions. The next is that effect will be falling on the bond pairs. Therefore, lone pair bond pair repulsions also there. Then strong force on the bond pairs. So bond angle decreases from 109 to 104.5 degrees. So this is 104.5 degrees, which is greatly affected. That's the important task is this one, 104.5 degrees is that. And this is the chart comparison with the 3 molecules, methane, ammonia and H2O. We can compare these 3 because they all have a common point is hybridization is sp3. But only the difference is type. The type is AB4, AB3E, AB3E2. Like this way. If you go with another molecules like this kind of way, you can observe this. Hope you have written this and I am taking another slide. Let us carefully observe. This is, now I want to compare the molecules are H2O, H2S. Here there is a question in the JEE exam. Whose bond angle is less and why? Between H2 and H2S, whose bond angle is less? The question is about bond angle and not about even the geometry, not about even the shape and that kind of. However, you can say the bond angle based on VSEPR hybridization and also effect of size on the central atom. In fact, oxygen group number is 6 plus monovalent are 2 by 2, that equal to 4. Here also same. Sulfur group number also 6, 2 monovalent, 8 by 2, 4. Both are sp3. This is sp3, it is also sp3 hybridization. Same hybridization. So when the hybridization is same, you might expect Same kind of bond angle. But the problem is size of the central atom is there. And observe. This is sp3 and you can say geometry. Anybody will say tetrahedral. Geometry tetrahedral. What is the type? AB to E2. AB to E2. Here also it is AB to E2, which means that shape also same for both, which is there. So shape of the molecule. It is also bent or V-shaped. It is also bent or V-shaped. Bent or V-shaped. Now coming to the interesting thing called bond angle. Here bond angle, you know, in H2 molecule in the previous slide I explained 104 degrees 28 minutes or 104.5 degrees. It is due to LP-LP repulsions followed by LP-BP repulsions. Same you can expect in H2S also, right? Only difference is size of central atom. Sulfur size is much bigger comparative to oxygen. When the size of central atom is more, what will happen? You know, lone pair distribution area increases. The interesting point you have to observe, bond angle affected by size. And this one in case of H2S, size of the central atom is more. And you better to understand this point, very important point, that is with increase of size, with increase of size of central atom, with increase of size of central atom, understand, the lone pair distribution area increases. The lone pair distribution area, increases. The lone pair distribution area increases. Whenever the lone pair distribution area increases around the central atom, what happens? Suppose let you imagine that it is belt shaped molecule. Here is a sulfur cell. Here it has lone pairs too. As the size is more, that lone pair can travel more distance, which is called wandering is more the distance. More the area it can wander. Therefore, it can put more pressure on the bond pairs. Interesting thing, lone pair repulsions are there, followed by lone pair and bond pair repulsions are there. Due to this more wandering distance, that will put more pressure on the bond pairs. Bond angle decreases very much, not slight decrease. Interestingly, its bond angle is 92.8 degrees is the actual value, reference value. So see this one. This is 104 degrees 28 minutes. While H2S molecule is 92.8 degrees. There is a tremendous decrease. In the examination JEE Main, they will ask what is the exact, closest value of the bond angle for H2S. Many students will opt like 104 degrees 28 or let it be 102 like that. But 102 is too much high. Actually, it's 92.8 degrees only. That difference is due to size of central atom. So, the point here I have written. Explaining again, with increase of size of central atom, the lone pair distribution area increases. Then what will happen? The result of that, what happens? Lone pair pressure on the bond pairs increases more. Therefore, LP-BP pressure more. LP-BP repulsions will increase. LP-BP repulsions increases more. When LP-BP repulsions increases, bond angle decreases. Bond angle definitely decreases. Same thing you can apply to another kind of molecule like ammonia and PH3. Always students should compare the molecules to understand the similar phenomena. Here I compared H2 and H2S. Suppose I am comparing now these two molecules. One is NH3, well-known molecule, ammonia, NH3, another molecule PH3. Now the comparison is between ammonia and PH3. In fact, both ammonia and PH3 both are belongs to same category because nitrogen and phosphorus belongs to same group number. That is the group number is 5. See, I will remind always, we need just within 5 seconds you need to develop. You can count also. Nitrogen group number 5, 3 more number. 5 plus 3, 8, 8 by 2, 4. 4 is sp3. Hardly 2-3 seconds to find the hybridization. Similarly, PH3. Phosphorus group number 5, 3 more number. 5 plus 3, 8. 8 by 2, 4. Same, 3-4 seconds. Not only hybridization, immediately sp3 means immediately geometry is tetrahedral. Immediate geometry, then type. There are 3 bonded atoms and 1 lone pair. So both are belongs to AB3E. So here I am writing hybridization. Same, it is sp3. That is I have done like this half into 5 plus 3 8 by 2, which is called 4. 4 means immediately sp3. Here also you got the same. That is half into 5 plus 3. That is also you got 4. 4 is called sp3. That is 4 sp3. Hybridization is done. Immediately any people will write geometry. Tetrahedral, tetrahedral. There is no difference. Whenever it is hybridization is geometry, you know what? It is tetrahedral only. So you have written tetrahedral. And what about the type? Type of the molecule. Both are similar, right? Because it is also AB3E, because 3 bond pairs, 1 lone pair. It is also 3 bond pairs, 1 lone pair. That's also AB3E. When the type is AB3E, definitely shape will be same. Both molecules shape is same. Now the shape. You know what? You know what I told you already? Whenever there is a lone pair on the central atom, geometry is different, shape is different. Now shape is pyramidal. You know already the ammonia is a pyramidal one. So this is pyramidal. It is also pyramidal one. It is also pyramidal one. Our important point is about bond angle. Bond angle. Bond angle in the case of ammonia is a well-known example, 107 degrees. I already told you. Because in the previous slide we have already mentioned ammonia bond angle is 107. Anybody, can you expect the bond angle for pH3 is what? It was the previous JEE question. So student feel, okay, ammonia, pH3 same type, same hybridization, so same geometry, same type, then same bond angle also they will expect. But size of the central atom is got increased. When the size of central atom is got increased, then comparative to ammonia, pH3 bond angle will be very less. Reason is, lone pair distribution area increases around the central atom is more. Hence, in case of pH3, as the lone pair distribution area is increased more, that will put more pressure on the bond pair. So therefore, pH3 bond angle decreases. You know what? For H2O, 104 degrees. From 104 degrees, it changes to 92. Almost like 12 degrees changes there. Same like this, but here is one lone pair. It also will decrease. Now here it is decreasing from 107. From 107 it will be goes to around 94 or 95 degrees. You can say 96 degrees also, no problem. This is 96 degrees is the bond angle for the case of pH3. Nearly to 96. It's not close to 104 or 105 also. It's not close to 107. There is a lot of difference in bond angle. The difference in bond angle is, reason is size of central atom. Size of central atom. Size of central atom is more. Size of central atom is more. Because of this reason, the bond angle has got much decreased. And still H2O, ammonia, pH3, like these molecules are simpler molecules. We will move on to little bit better examples. Concept is same. You can apply half into Z plus M. You can develop 5 major characteristics. Including lone pair you can develop, that is the most important characteristics. Let us go through this point that suppose I am giving you SOCl2, SOCl2. Let me write again. The molecule is SOCl2. SOCl2, which is called, thionyl chloride. One of the important examples. Thionyl, THIONYL. Thionyl chloride. Thionyl chloride. You know what SOCl2 is having vapors. If you inhalate the vapors, you can sense that, and there might be eye irritation also there with SOCl2, which is called a thionyl chloride. Right? Thionyl chloride, how can you develop those things? Here the central atom is what? So some people will find the student get a doubt. What about how to identify a central atom? Here is a sulfur or chlorine or oxygen. And somebody will feel oxygen is at the middle, so therefore some people will feel that oxygen is the central atom. No, sulfur is the central atom. How do you can identify central atom is what? Usually, you know what? Central atom is simply a low electronegative element among the all. But their exception is there for hydrogen. Never count about hydrogen, because nowhere hydrogen is central atom. There is no such molecule. Other than hydrogen, remaining elements, whichever is having the lower electronegative element, that will be considered as central atom. Now, oxygen, sulfur, chlorine. Which is the lowest central atom? Sulfur. Because oxygen is second highest electronegative element. First highest is chlorine, second highest is oxygen. And chlorine is also third and fourth highest electronegative. Sulfur is less. So, sulfur group number is 6. 6 plus, monovalent are 2. 6 plus 2, 8. 8 by 2, 4. 4 is sp3. I told you about 5 seconds. I can reduce, I'm just saying 5 seconds. In fact, that is 2 seconds only. You can do within 2 seconds about hybridization of any molecule. No limitations. Understand? Any covalent molecule, not about ionic molecules. Now, it is sp3. Immediately we can say geometry is tetrahedral. Tetrahedral is geometry. Tetrahedral geometry is there. See, the geometry is tetrahedral. Geometry is tetrahedral. And let is important, you can write sulfur. You have written. You have to write the tetrahedral shape. Important point is this one. First, you should write the shape of the bonds and not the, don't put the atoms like 1 oxygen, 2 chlorines, don't put those things. Just you write bonds based on the geometry. It's the tetrahedral, so you write 4 bonds only. That is the point you should observe. Then, there is a 1 oxygen and 2 chlorines. So, let it be 1 chlorine is here, 1 more chlorine is here. Suppose 1 oxygen you have written. But you know what? Oxygen is a divalent atom. Okay, all 3 atoms are done. So, what about this one means? It is called lone pair. It is called lone pair. Now, oxygen, for oxygen you can use a pi bond because oxygen is a divalent atom. You can put pi bond. Now, suppose anybody are asking, how many bond pairs are there in SOCl2? Actually, bond pairs are 3 and not 4. 4 is wrong. 3 is correct because only sigma bonds are called as a bond pair. Sigma bond is only 1 here. And this is also 1 sigma, it is another sigma. So totally 3 sigma bonds. You may ask a question that pi bond also bond, why you are not counting a bond pair? See, what formula you applied? Number of hybrid orbitals. Number of hybrid orbitals is equal to half into Z plus M. Hybrid orbitals always form sigma bonds. We have to count only sigma bonds, not the pi bonds. That is the logic behind the point is. Pi bond also bond pair, but here we don't count. Because we are counting the number of hybrid orbitals by which it forming the number of sigma bonds only. It's not the characteristic of pi bond. You can keep pi bond, no issue. That's why even I put with a different color. See, 3 bonds are there and this is a lone pair. So, type is there AB3E. AB3E is the type. Type is important, you know well already. Because in the Whisper theory and combination with the hybridization, you need that. So, type is AB3E and definitely any AB3E molecule is a pyramidal one, like similar to ammonia. It is also pyramidal like. So, AB3E therefore shape will be pyramidal. Shape is pyramidal. Shape is pyramidal. And bond angle is, actually NH3 means bond angle is 107 degrees. But here you may say bond angle little different because there are 3 different bonds. Double bond O, chlorine, 1 different bond. Chlorine, chlorine, another different bond. Another is chlorine to oxygen. And there is the lone pair. So, anyhow, bond angle is even chlorine, chlorine, between chlorine and chlorine bond angle is more because you know lone pair repulsions of the bonded atoms. Bonded atoms have repulsion, therefore here the bond angle is more. Comparative to here, let you take that A bond angle and you take that B. Here bond angle is B greater than A. Here the bond angle is B greater than A. Even that point also you can cover based on this way. And we can keep on moving with the different molecules. Like, let us observe this one. POCl3, phosphorus oxychloride, phosphorus oxychloride, phosphorus oxychloride, phosphorus oxychloride. See, I can say this is so simple still because central atom is phosphorus. Phosphorus group number is 5 again. Plus 3 monovalent. 5 plus 3, 8, 8 by 2, 4, 4 is sp3. Any molecule less than 3-4 seconds, our target we are reaching. And you will become better than any of the student outside because you are having the shortcuts. So, important thing is for shortcut, for deriving 5 points. Geometry, shape, that all the things. So, 5 plus 3, 8, 8 by 2. That is that 4 is sp3 tetrahedral geometry. Immediately you can draw the bonds. You can keep the phosphorus and you can put the 4 bonds. There are 3 chlorines. Yes, you can keep 3 chlorines. There is a 1 oxygen. Yes, you can keep oxygen. But you know well that oxygen is a divalent. So you can keep oxygen as a double bond. And don't count that pi bond as a bond pair because we are counting number of hybrid orbitals which will form only sigma bonds. Therefore, bond pairs are 4. It is their AB4 type molecule. Type is AB4. So, the molecule type is AB4. Type of the molecule AB4, and I no need to mention that when the type is AB4, it doesn't have a lone pair on central atom, therefore geometry and shape are similar, which is called tetrahedral. And it's like reference molecule, like methane. But methane, all the four are same bonds, but here is one bond is double bond O, another three are chlorines. This is POCl3 molecule, and its geometry, shape, both are tetrahedral, and you can write that it is like tetrahedral only. This is the way you can write. We'll go through a better molecule. You know what? In the previous JEE, that means JEE main. In JEE main, previous JEE main, mostly important examples are like this: XeF2, XeOF4, XeO2F2, XeO2F2. These are so many times asked about these three molecules, and they are interestingly good because they are having xenon with two fluorines. Xenon group number 8, 8 plus 2, 10, 10 by 2, 5, sp3d. Got it? 2 seconds enough. So that is there. 8 plus 2, 10, 10 by 2, 5. Immediately we can say sp3d, trigonal bipyramidal. But it has two bond pairs only, which means that remaining three are lone pairs. So type is AB2E3. Interesting, that is that. So it's a linear molecule. So we'll write that molecules. Similarly, XeOF4, first we will predict the hybridization. Xenon 8 plus 4 monovalent, 8 plus 4, 12, 12 by 2, 6. Immediately we are getting 6. Immediately you can say sp3d2, which is called octahedral. Then XeO2F2, 8 plus 2, 10, 10 by 2, 5, sp3d, 5 you are getting, therefore sp3d. And type also important. See, XeF2, 2 fluorines only, therefore it is AB2E3, because it's sp3d means 5 out of 3 lone pairs, AB2E3. Whereas XeOF4, total 6, out of 6, 4 bonds, and oxygen also 5, total 5 bonds. So AB5E, AB5E is that. And what about this one? This is total 5, out of 5, 4 bonds. So AB4E2, AB4E, not E2, AB4E, because total hybrid orbitals are 5, out of which 4 are bonds. Therefore, 1 is a lone pair. AB4E, AB4E, AB5E, AB2E3. And those structures you need to practice. Suppose our molecule is XeO2, XeF2, XeOF4, that kind of. If you see this one, XeF2, XeOF4, XeOF4, XeO2F2. And already I developed those things. 8 plus 2, 10, 10 by 2, 5, 5 is sp3, sp3d, sp3d, which means that trigonal bipyramidal. This is called hybridization. This is geometry. Then type. Type is what? Total 5 bonds, but 2 are there. Therefore, AB2E3, AB2E3. And therefore, the shape, how it looks like, you have to write bonds. Suppose central atom is at the xenon. 1, 2, 3, 4, 5 you have to represent, out of which only 2. So you keep one fluorine here, you keep another fluorine here, and these are the lone pairs. Interesting thing molecule is this one. And this is a linear molecule. And geometry is trigonal bipyramidal, but shape is linear. It looks linear only. These lone pairs are invisible. Lone pairs are invisible, therefore it looks like linear. In JEE, there is one more question also asked about XeF2. You know what? How many total lone pairs are present in XeF2? Many of the students answered is 3. Okay, but actual answer is not 3. You know what? Every fluorine can have 3 lone pairs. Any fluorine also have 3 lone pairs. Therefore, total lone pairs are 9, because 3 lone pairs on the xenon, 3 plus 3 lone pairs on the 2 fluorines. The question is total lone pairs. If the question is how many lone pairs on the xenon central atom, means you can say 3, but it is not on the central atom. It is all about the total lone pairs. Answer will be 9. Same example given in JEE 2021, that I3 minus charged molecule. I3 minus also belongs to AB2E2 type, because I3 minus means iodine central atom, 2 monovalent, 7 plus 2, 9, 1 charge, 10, 10 by 2, 5, 5 sp3d, out of which 2 bonds are there, AB2E3. You can follow this kind of trend. So which will be there this way. It is, shape is linear. So now the shape is linear molecule. Shape is, this one is the linear molecule. This is Linear is the shape. And you know bond angle is 180 degrees. So bond angle is 180 degrees. Dipole moment also 0. Here mu, dipole moment also 0 because that's equally distributed. One fluorine at the top, bond moment is towards upward direction. Down fluorine is bond moment is downward direction. They are mutually cancelling. And lone pairs are equilaterally present among the three corners. So no effect of the lone pair for the dipole moment. So understand one thing, not only 5 characteristics within 5 seconds, you can say about dipole moment also, which is called the mu. It's a Q into D. It's a product of Q into D, distance into charge. For for PCl5 also 0, CH4 0, it is also 0 because here the lone pairs also equally distributed. XeOF4, 8 plus 4, 8 plus 4, 12. 12 by 2, 6 is sp3d2. You can say sp3d2. Immediately octahedral. Immediately type is what? 4 plus 1, 5. AB5E. This is important. How to guess the shape of a molecule for AB5E? Central atom is A. There are 4 bond pairs. 1, 2, 3, 4. On the same plane there are 4. Above there is 1 and below there is 1. That is called octahedral. But actually only 5 bonds are there here. Because it is there having only 5 bonds, not 6 bonds. It is having totally 5 bonds. So, which means that, you know what, on the same plane 4, one top, one down, right? You keep one atom on the top, another atom will be down as a lone pair, which means it's a square pyramid. From the top it is like pyramid only, and it is square pyramidal. AB5E is always square pyramidal. AB5E is square pyramidal. Square pyramidal. This is square pyramidal one, which will be like this way. Central atom is xenon, and you take 1, 2, 3, 4, 5, 6. I have written octahedral way. This is the way that octahedral way is mentioned. But out of that octahedral way mentioned, there are 4 fluorines. You can keep 4 fluorines like this way. 4 fluorines, 1 oxygen. Suppose this is a lone pair, definitely there is an oxygen here. You know well, oxygen is a divalent. No issue, you can put the pi bond. This is the way. It is a square pyramidal one, which is called square pyramidal. And you can say bond angles also. Bond angles almost existing 90 degrees only. From the top also 90 degrees. From this to this 90. From this to this also 90. From this to this also 90. There are 4 90 degrees bond angles. But down is a lone pair that can disturb the bond angles. Therefore, exact 90 degrees are missing. Okay, but actually nearly 90 degrees bond angles are 4 from here and 4 from here. There are 90 degrees bond angles. There are 4 plus 4, 8. That equal to, there are 8 are having. 8 bond angles of 90 degrees are there in this molecule, which is called XeOF4. Now coming to this molecule, which is called XeO2F2. Same like this, same procedure. 8 plus 2, 10. 10 by 2, 5. 5 is sp3d. sp3d. Immediately you can say TBP, trigonal bipyramidal. That means 3 on the same plane, 1 top, 1 down. We can write a bonds. First you keep the xenon and you write 1, 2, 3, 4, 5. Out of which 2 oxygens, 2 fluorines. Peculiarly, this is very important. You have to keep this one, especially this one as lone pair. Remaining all you have to keep the bonds. 2 fluorines and 2 oxygens. One of the oxygens is this one. This is another oxygen, double bond. It is fluorine. It is also fluorine. You know what? It looks like this particular shape is called seesaw. This shape is called seesaw. There will be a stand and there is a kind of slate like this way, which can be used this kind of way, like kids can play in the children's park, which can have a seesaw. This is a seesaw and this is seesaw. This is seesaw shape. Shape of the molecule is this one, and this molecule is very important molecule. This is one of the very important molecules about geometry, shapes and affected by the lone pairs. This lone pair is disturbing and the type is AB4E. Any AB4E, any molecule is seesaw. Any AB5E is shape is square pyramidal. Any AB5E is square pyramidal. This is AB to E3. Any AB to E3 is linear. Any AB to E3 is linear. Any AB5E is square planar and any particular AB4E is seesaw. This is the way that you can develop the geometry, shapes, hybridization, type and shape of the molecules within fraction of seconds you can do. That's kind of things you have to go for with the different molecules. You can go for some more molecule, whatever is needed. Not only xenon compounds, we have even other so many compounds like phosphorus oxyacids are there, which is called H3PO4, H3PO3, H3PO2, H3PO2, and another very important concept of examples. Here I am not taking one example. I am taking three example comparison also. You can have a clarity while I am explaining the things. Let us observe. If we are going through these molecules, you should know the names of the molecules also, which is H3PO4 called phosphoric acid, phosphoric. This is phosphoric acid. This is phosphorus, PHOS, PHOROUS, phosphorus acid, and this is hypophosphorus acid. Hypophosphorus acid. This is hypophosphorus acid. Interestingly, here the names of the compounds also important, because suppose a question is asked, what is the type of molecule hypophosphorus acid? Then done the matter. If you don't know the formula, then the question you can't answer. So observe this one. H3PO4. See that hybridization, how the way I am counting? Simple. 5 plus 3, 8, 8 by 2, 4. 5 plus 3 by 2, 8 by 2, 4, sp3. Immediately we can say fraction of seconds. Same like this. Same 5 plus 3, 8, 8 by 2. That is also 4, which is sp3. Same like this all the way, that also. 5 plus 3, 8, 8 by 2, 4. All are having sp3. sp3, sp3, sp3. But after that, if matters are changing, many students will fail in answering about H3PO2, what is its type, and similarly, what is its type of H3PO3, that is the matters. Suppose even after learning this much by this session, some people will make a mistake in this one. That's why I am giving a precautionary measure I am giving you. Let us observe. It is there, so you can keep phosphorus here, 1, 2, 3, 4 bonds you are keeping because tetrahedral. So, but you can check it, there are 4 oxygens. Okay, no problem. 1, 2, 3, 4 oxygens. Where you can keep the hydrogens? These are called oxyacids. Oxyacids means hydrogen should be present on the oxygen. Here is a hydrogen, here is a hydrogen, here is a hydrogen. They won't count in the particular structure. Now, actual structure is this one, which is called tetrahedral. And phosphorus oxygen is the divalent. So for this divalent, okay, managed. For this you have to keep a double bond O, because oxygen is the divalent. That also counting. And here is AB4, no lone pair. Therefore perfect geometry tetrahedral. And there is no deviation because no lone pair on central atom. Coming to this molecule, again the same thing, phosphorus, 1, 2, 3, 4 bonds. But thing is, there are 3 oxygens only. 1, 2, 3. And there is one is missing, and that you have to keep it lone pair. Students will do mistake is, yes, there is a chance that this you might put a lone pair, there is a chance, but the actual thing is, lone pair is not available here. You remember one shortcut. I will give you one shortcut thing here is, in the oxyacids containing 1 or more oxygens, at least 1 oxygen should be double bond O. You keep in mind this point, then you don't do mistake. That means here you have to keep double bond O. Okay. Then how many hydrogens? 3. One of the hydrogens is here, second hydrogen is here. You have to keep another hydrogen directly here. There is no lone pair on the central atom. If that point is missing, which point? One oxygen have a double bond O. If you know that point, you don't do mistake. If you don't know that, you will do mistake. That's what I told you, like a precaution. So you should follow this one. A very important molecule. This is a very important molecule, because the chance for the finding the type. Now the type is AB4. Still it is also AB4. AB4. Interesting thing is, this proton is releasable. This proton is releasable. This proton is non-releasable proton. Whenever the hydrogen attached to directly the central atom, that won't release. That means it is not as a part of acidic nature. But when the hydrogen is connected to oxygen, that hydrogen can be released as a acidic proton. Therefore, the basicity of phosphorus acid is 2, not 3. But phosphoric acid is 3. While coming to the hypophosphorus acid is the more important again. Let us observe this one. See this one. Now coming to this one. Same sp3. I kept phosphorus here. I kept 4 bonds. And I have seen how many oxygens? 2. But I got remembered one shortcut that what I explained. Now you know what double bond O is compulsory. 1 oxygen. Then you keep 3 hydrogens. 1 hydrogen is here. Oxygens all are done. Then you have to keep the remaining hydrogen. Total 3 hydrogens. You can have 2 more hydrogen possibility. That means it is also AB4 type. All 3 molecules are belongs to AB4 type only. Some students will answer that the AB3E or AB2E2 like that they will answer. But if you keep in mind that in the oxy acids, one of the oxygens should be a double bond O, then you don't do any mistake. Keep this mind. And now this is also AB4 type molecule. It is also perfect tetrahedral molecule. And interesting thing is that it is the acidity is 1, which is called basicity actually. This is the basicity value is called 1, basicity value 1. Here the basicity is 2. Here the basicity value 2 because number of releasable protons are important. Here the releasable protons are 2. Here the basicity is 3. Here basicity is 3. Here the basicity is 2. Here the basicity is 1. So finally I am concluding one more thing. Within fraction of seconds, what you can identify? Number 1, hybridization. Number 2, geometry. Once the geometry is done, you have to do the type AB3E or AB4, AB2E2 like that. Once the type is done, you have to say the shape. After the shape, you can say bond angle also. Now, along with the 5 character 6, you can have one more character 6 called acidity, or we can say that the basicity of a compound, basicity of an acid. Basicity of an acid, especially these 3 examples, plays a major role. That is H3PO4 contains 3 hydrogens. All 3 are releasable protons because they are attached to oxygens only, not the central atom. While coming to H3PO3, the hydrogens are present on the oxygen, they can release. The hydrogens present on the central atom, they can't release. Say, here H3PO3, only 2 hydrogens present on the oxygen. So, they can be releasable protons. One of the hydrogens is directly connected to phosphorus, it can be released. Therefore, basicity became 2. Hope you understood. And this one, H3PO2 molecule. There, it is AB4, all 3 are AB4 only. But only one hydrogen is connected to oxygen. Remaining hydrogens are directly connected to the central atom phosphorus. How do you identify central atom is phosphorus? Means, I already told you, identifying central atom is based on its electronegativity. As the phosphorus electronegativity is less than the oxygen, so phosphorus is central atom. Because oxygen cannot be a central atom because there are 4 oxygens, there are 3 oxygens, there are 2 oxygens like this. This screen, whatever is appearing on the screen is also matters because you can identify along with the 5 character 6, you are identifying one more thing called basicity. That is also done. Now, in the next slide, see the bond angles affected based on the bonded atoms lone pairs. Suppose this is H2O. One molecule is H2O. Another is OCl2. OCl2. H2O, OCl2. H2O is a very popular molecule, water molecule. You know its bond angle is 104.5 degrees, 104 degrees 28 minutes. Anybody can expect that bond angle in OCl2 will be more than 104 or is it less than 104? What kind of way? Simple clarification I will give you. See this one. H2O, well-known molecule, same like this. Again we follow 6 plus 2, 8, 8 by 2, 4. 4 is sp3 hybridized. It is also same. 6 plus 2 monovalent because halogens also called monovalent. 8, 8 by 2, 4. That is also sp3. Both are sp3. Okay, and both are having type also same. It is Ab2E2. It is also Ab2E2 type molecule. Both the molecules are belongs to Ab2E2 type only. Then you can expect the bond angle should be nearly similar. But see the changes, observe. This is the oxygen molecule, oxygen atom is there, hydrogens are there, it is a bend shaped molecule, it has one lone pair and it has another lone pair. It is called Ab2E2. I told you that there are having lone pair repulsions, thereafter lone pair repulsion. That means LP are greater than BP repulsions. Lone pair, bond pair. Because of that, its bond angle is 104 degrees 28 minutes. Coming to this molecule, which is called OCl2, oxygen is there here, chlorine is here, one more chlorine is there. Now here is not the problem on the central atom, because in both the molecules, central atom is same oxygen, central atom has two bond pairs and two lone pairs same. That characteristic is same. But what is the differentiating point means the bonded atoms. Here the bonded atoms are hydrogens, it doesn't have any lone pair. While coming to this OCl2, you know well, any halogen can have three lone pairs. Now I can show there are three, one lone pair, second lone pair, third lone pair. There are three lone pairs on chlorine. Same, one lone pair, second lone pair, third lone pair. There are three lone pairs on this chlorine. See, whenever this is there, chlorine is a bulkier, bigger atom. That means it occupies more space on in the open area. So therefore, this open area chlorine and this chlorine can have lone pair repulsions are there. Here the point is LP repulsions. LP repulsions dominates. LP repulsions of bonded atoms. LP repulsions of bonded atoms. Bonded atoms, it dominates. LP of bonded atoms getting the dominated. Because of that, you know, that chlorine, it is there, chlorines are like this way. Now this chlorine lone pairs 3. This chlorine also have 3 lone pairs. They have repulsions, not the central atom lone pairs. Now due to this lone pair repulsion, this starts moving like this because of some lone pair repulsion. Therefore bond angle, in fact it is here normally, now it is increased like this way. It will be around 111 degrees. You remember OCl2 molecule, the bond angle is 111, which is very higher than the expected. Shockingly, it is greater than the reference value 109 degrees. Actually, sp3 hybridization is the reference is 109 degrees 28 minutes. But in OCl2, this value became 111 degrees. 111 degrees. You can remember easily the value also. That's the interesting thing about the bonded atom lone pairs also plays a role in identifying the bond angle. Got it? Let us go through some more examples. Not only any kind of examples you can select, like H2SO4. H2SO4. Here I am giving you another very important characteristic. Now the point is, all of you students know about sulfuric acid, which is called H2SO4. I am giving you a new molecule which is called H2SO5. Anybody can answer what about H2SO5? H2SO5. The molecule is H2SO5. Comparison with H2SO4. We are taking two molecules now. Let us observe. One is H2SO4, another is H2SO5. H2SO4, another is H2SO5. In fact, many of the students don't know what is H2SO5 is actually. It's a kind of more interesting thing and a more important molecule as per the JEE exams. H2SO5 name is peroxymonosulfuric acid. This is called peroxymonosulfuric acid. Peroxymonosulfuric acid. Based on the oxidation state method, that means what is the sulfur oxidation state means? Some students will do like this. 5 into -2 -10 +2 sulfur hydrogens are +2 -10 +2. So there should be +8. Student will answer +8. You know, sulfur group number is 6. Maximum oxidation state should not exceed the 6. Therefore, it should be 6 only. +6. How it is possible means, out of 5 oxygens, 3 are normal oxygens, 2 are peroxy oxygens. That means it is -1, it is -1. -2, -2, -2. So -6 and -2. Total -8 only. Here total is -8 and that is a +2 cancelled. Therefore, it is a +6. Sulfur is +6. Opposite is +6. So sulfur is +6. Based on that, you can develop the structure. So understand something. If you apply hybridization, like our point, half into Z plus M, sulfur group number 6 plus monovalent are 2, 8 by 2, 4. You are getting sp3. That means sulfur you take 1, 2, 3, 4 bonds. Oxygens are 4. You can keep 4 oxygens. Okay. But there are 2 hydrogens. 1 hydrogen here, 1 of the hydrogens here. And automatically you collected a shortcut what I told you. That's what you know. At least in the oxo acids, minimum one oxygen should be a double bond. But here there are two. You can keep double bond or double bond because oxygens are divalent. And no doubt for H2SO4 is this structure, and all of you know about H2SO4, tetrahedral molecule, AB4, no lone pair on central atom, no deviation in the shape. Shape also tetrahedral. Now coming to H2SO5 molecule. This one, it is also same like this. Sulfur is there here. 1, 2, 3, 4, you can keep it. Interestingly, there are 5 oxygens. How can you put 5 oxygens? There are 4 bonds only. Now, 1, 2, 3, 4. Okay. Just now I told you that this molecule have a peroxy bond. Peroxy bond called O, single bond O. Which means that anywhere you can take, any one of the cases you can keep as oxygen, O bond O. Total hydrogens are 2. Oxygen is a divalent, so finally one hydrogen here you have to keep it. One more hydrogen here anywhere you can write. And all are done. And that 2 oxygens normally double bond O, normally double bond. That is H2SO5. And that H2SO5 also geometry will be same, which means AB4 only. Interesting that up to this only you have to count, not about this oxygen. That oxygen is not in the part of central atom. Therefore, this is AB4 type only. It is also AB4. This molecule AB4. AB4. This is also AB4 only. It is tetrahedral shape. Tetrahedral shape. It is also tetrahedral shape. It is also tetrahedral shape because whenever the type you are getting, then no doubt AB4 means tetrahedral only, right? There is no deviation. Whenever it is AB4, it is tetrahedral only. You have got tetrahedral only, and no difference. Even the bond angle is also not affected. Close to 109 degrees 28 minutes, close to 109 degrees 28 minutes. But why this is important? Because you know the logic is what? People will miss about peroxy bond. There is a peroxy oxygens are there. That's why you can identify this way. Okay. And some students will get a doubt. Suppose an expert like me, if I am asking what is hybridization in a molecule like H2S2O7 or H2S2O8, then student get a doubt. Let us carefully observe this molecule, what I am asking. Now my question for the JEE main level, I am asking you that this way. H2S2O7. Similarly, H2S2O8. Of course, not so simple. It's not so simple. They are just higher levels of JEE main. H2S2O7. In fact, based on oxidation number method, you can do this also. And here at this juncture, at this condition, you can't apply half into Z plus M because half into Z plus M is applicable whenever there is a one central atom. Here there are 2 central atoms, which is called poly central atom molecule. Poly central atom molecules don't apply half into Z plus M. You can develop based on the oxidation state. So that means what I am explaining is that based on oxidation state method you can apply. Based on this method you can identify. That means what? See this one, plus 2 plus 2x. There are 2 sulfurs. Minus 14 because oxygen is minus to 7 oxygens minus 14 is equal to 0. Therefore, that is 2x minus 12 equal to 0. So 2x is equal to plus 12. Obviously, x is equal to plus 6, and no doubt sulfur is plus 6 oxidation state. From that you can develop it, but let us see here is that plus 2 plus 2x minus, if you write 16, it collapses. It's not 16 because I told you there is a peroxy. Minimum one peroxy bond means 2 oxygens as peroxy linkage. That means 2 oxygens as minus 1. Remaining 6 oxygens is minus 2. 6 into minus 2, minus 12. 1 oxygen minus 1, another oxygen minus 1. Total is minus 14. And you have to write 14 only and don't write 16. And therefore, this is equal to 0. Then it will be what? This is plus 2 plus 2x. This is, therefore, 2x minus 12 is equal to 0. Here also x is equal to plus 6. This is correct. This is the perfect procedure. But you know, student will get a confusion in writing this part. Generally, they will write like this. Plus 2 plus 2x minus 8 to 16 is equal to 0. If you take like this, you will get a wrong answer. You will get x value, will get a plus 8, which means incorrect. Incorrect, from the incorrect you can identify a point that there is the existence of peroxy linkage. From this you can identify, therefore peroxy linkage is there. Therefore peroxy linkage is there. Peroxy linkage is there. Based on this you can write the structures of these two molecules like this way. H2S2O7. This way you can write like this. Sulfur you can keep it here. You can take one more sulfur. Total oxygens are 7. In fact, there are 2 hydrogens only. H2S2O7, H2S2O8. Only 2 hydrogens. That means here you can keep 3 bonds. One is like this. Here also 3 bonds like this way. One is OH. Here also one is OH. One of the hydrogens is normally like OH. For this, for that also. Totally 7 oxygens. So here you have provision for 3 more oxygens. See, 1 oxygen here, 1 oxygen. 3, 4, 5. Total 6 oxygens. One is at the middle you have to keep. Systematically you can draw its structure. Now this is as usually double bond O. It is also double bond O. It is double bond O. This is also double bond O. You got this structure. From this you can draw the geometry. Geometry is this one. It is tetrahedral geometry now. This is tetrahedral. The geometry is tetrahedral. From geometry I am saying hybridization in a reverse way. Now tetrahedral geometry is there, so I can say hybridization is sp3. That's why now hybridization is sp3 here. So sp3 hybridization with ab4 type also. ab4 type at one side. This is A, central atom is A. 1, 2, 3, 4 bond pairs. ab4. Same like this. ab4 here also. There are 2 ab4 structures. It is also ab4. It is also tetrahedral. It is also what? Tetrahedral geometry molecule is there. 2 parts are there. Each part is tetrahedral. Each part is sp3 hybridized. And this one, I explained about that molecule only. That's why H2S2O8 is needed. That means sulfur, another sulfur is there here. As usually there is a 1 OH. As usually there is 1 OH is here. And there is a double bond O. Here is also one more double bond O. Same as like this. Here is also double bond O. There is one more double bond O. Total 3 plus 3, 6 oxygens was done. You have 2 more oxygens. I told you and you already understood that is a peroxy linkage. Means O bond O is there. You keep both the O at the middle. That means here there is a peroxy linkage. O bond O is there. Done. Point is done. And still that is tetrahedral. This is also tetrahedral. Both are tetrahedral. This is one tetrahedral part of the molecule. This is another tetrahedral part of the molecule. That's 2 are the 2 tetrahedral units are connected by adjacent atoms, not on the same atom. This is one tetrahedral unit. This is another tetrahedral. Both are not connected to the same atom. While in H2S2O7, that molecule, both tetrahedral are connected on the same atom. But now, in this example, both are connected on adjacent atoms. Here is one oxygen is separate. Here is another oxygen is separate. That is the way that you can have. It is sp3 hybridized. It is also sp3 hybridized. It is sp3, that is also sp3. That is tetrahedral. This is also tetrahedral. Suppose, actually this H2S2O7, H2S2O8 belongs to 12th standard question because that is relating to oxyacids of sulfur, which is belongs to p block elements. But on what basis I developed this one? Based on chemical bonding of 11th standard. So if you are extremely good in hybridization VSCPR, you can solve 11th examples as well as 12th standard examples undoubtedly without any error. That's what this today's session, what I explained is about majorly about 5 characteristics with within fraction of times less. That means within 5 seconds, how can you do that? Within 10 seconds, how can you do that? For that, you need a tabular form relating to group number of central atoms like boron, aluminum, gallium, 3rd group, carbon, silicon, germanium, 4th group, nitrogen, phosphorus, arsenic, 5th group, then 6th group, oxygen, sulfur, selenium, 7th group, fluorine, chlorine, bromine, iodine. If you have that, it is enough. You can go with half into Z plus M form. And now, we can move on to charged molecules. Okay, let us observe this one. About charged molecules. Charged molecules. Okay, charged molecules. Charged molecules. What are called charged molecules? Let us say, for example, it was the previous JEE question. Previous JEE question is about I3 minus. In the previous somewhere also I spoken about I3 minus. I3 minus is a previous JEE question. 2-3 years consecutively that was asked about I3 minus geometry or shape. I3 minus 3, this will be written as I2 minus. I2 minus. You have to write like this way, which means that one iodine is central atom and two are bonded atoms. So you can see this group number of iodine is 7. 7 plus monovalent or 2. 7 plus 2, 9. Charge is there, you have to add plus 1 for that. 9 plus 1, 10. 10 by 2. 5 is there, that is sp3d. sp3d. sp3d immediately you can say trigonal bipyramidal. That means iodine is at the central atom. 1, 2, 3, 4, 5. 5 bond pairs. Now, total 5 bond pairs. But atoms are only 2. Bonded atoms are 2. You can keep one iodine here, one iodine is here. AB2. What about these 3? 3 lone pairs. One lone pair, second lone pair, third lone pair. They are equilateral available and it looks like a linear shape only. The shape is linear, but geometry is actually trigonal bipyramidal. But its shape is linear molecule, similar to XeF2. XeF2 and I3 minus are isostructural species. Isostructural means having same type. It was the previous JEE question. Isostructural means what? Isostructural means not having same hybridization, not having same geometry, not having same shape, but having same type. If it is, suppose CO2 is linear, XeF2 also linear, will they isostructural? No. CO2 sp hybridized and is AB2, whereas I2 minus is sp3d hybridization but linear. Type is different. That type is different. They are not isostructural. XeF2 and I3 minus are isostructural because both are sp3d, both are AB2E3. It is also AB2E3 type. So the type is AB2E3. 2 bond pairs and 3 lone pairs are there. Any AB2E3 molecule is linear. And the same question asked, in the I3 minus molecule, how many total lone pairs are there? It was given in 2023 JEE Mains. The answer is 9 actually, because there are 3 lone pairs on central atom and there is 3 lone pairs on each iodine also. This iodine also have 3 lone pairs. You don't expect that. Many of the students opted answer is 3, but actually answer is 9, because 3 lone pairs on central atom and 3 each on each bonded atom. Total will become 9, and that is an important question also. It is called. So now what I am saying to say is, for charged molecules, the formula will be half into G plus M plus or minus C. You have to use this formula for number of hybrid orbitals. Number of hybrid orbitals is equal to this one. And this is the charge, this is the formula you have to use. And here is, you can take plus C for anions, plus C for anions, and minus C for cations. Cations, because cation means it is a loss of electron. There is a shortage of electron there, which means that minus is the sign. Anions means extra electrons, which means that there is the addition of electrons, which means the plus C you can use. For that plus C, this is minus you have to use. So I hope you understood. For the charged molecules, you can do this way. Alright, and you can expect any kind of thing. Suppose even if you go with NH4 plus, you can use group number of nitrogen is 5, monovalent are 4, positive charge means minus 1 you have to use, minus 1, 5 plus 4, 9 minus 1, 8, 8 by 2, 4, 4 is sp3, sp3 immediately tetrahedral. You can keep nitrogen 1, 2, 3, 4 bonds because tetrahedral. Already 4 bonds are available. Yes, you can use 4 hydrogens, and totally there is a charge on the plus 1 on the entire molecule. Actually, it's on the nitrogen, no issue. And this is the way, it is tetrahedral geometry. It is tetrahedral geometry, which is ammonium cation, which is called ammonium ion, AMMONIUM, ammonium ion. So the ammonium ion is there in tetrahedral geometry, which is a charged molecule. Any charged molecule you can go through. Suppose IO3 minus, iodate ion. IO3 minus called iodate ion. Iodine group number is 7 plus monovalent are 0. See this, because oxygen is a divalent, so we don't count monovalent atoms. So 7 plus 0, charge is 1, plus 1, because that is a negatively charged. Negatively charged molecules have to use plus charge. So plus charge magnitude is 1, therefore 7 plus 1, 8, 8 by 2, 4, 4 is sp3, Based on that, immediately you can write sp3. So tetrahedral. Iodine you can keep it. 4 bonds you can write tetrahedral geometry. 1, 2, 3, 4 bonds. And total oxygens are 3. Suppose let it be 1 oxygen, second oxygen, third oxygen. All 3 was utilized. And what about this one? Don't worry, it is a lone pair. Where is the minus charge? Any on one of the oxygens you can keep minus charge. Here I am keeping a minus charge. Oxygen is a divalent, so I have to keep a bond. That means it's a pi bond. It is also pi bond. Clear? This is single bond only because there is a negative charge on that. So which will be this one? And the molecule appears this way. Total is called tetrahedral. Total it looks like tetrahedral, but the type is AB3E. AB3E because there are 3 bond pairs and 1 lone pair. Any AB3E molecule is the pyramidal one. So shape is pyramidal. Shape is pyramidal. Shape is pyramidal one. This is the molecule shape is pyramidal. This is the way you can develop it. For any charged molecule, not only IO3 minus, you can say IO4 minus also, periodic ion because HiO4 called periodic acid. If you take 4 oxygens, it will be tetrahedral. IO4 minus is tetrahedral only. IO3 minus. Immediately you can go with sulfur dioxides, SO2. SO2 without any charge. SO3. SO2 is a bent shaped because sulfur group number 6 no monovalent. 6 by 2, 3. Trigonal planar sp2. But there are 2 bond pairs, 2 oxygens. So bent shaped molecule. And you can say bond angle also. There is a 1 lone pair. Expected is 120, but lone pair put pressure on the bond pairs. Therefore, it is less than 120. Exact bond angle in SO2 molecule is 119, 119. That is the way you can develop the perfect about the bond angles also, not only geometry, not only shape, not only the type of the molecule also. So, this is the way you can develop those things. Any kind of related molecule like you can go through. H2SO3. Suppose if I have given H2SO3, some random examples I am giving. SO3, otherwise SO4 2 minus sulfate ion, CO3 2 minus carbonate ion. Any particular molecule you can go through, no problem. For this SO4, sulfur group number is 6 plus monovalent are 0 plus 2, 6 plus 2, 8 by 2, 4. 4 means sp3, tetrahedral. Done. About this SO4 2 minus is this one. About this one, carbon group number is 4 plus monovalent are 0 plus 2 charge, 6 plus 2, 8, 8 by 2, 4. It is also carbon group number is 4, but 0 monovalent plus 2, 6 plus 8, 4 plus 2, 6, 6 by 2, that is the 3. That's what? That is the 3 because that is 4 plus 2, 6 by 2, 3. 3 means sp2. That means hybridization is sp2. sp2 means trigonal planar. You know what sp2 is a trigonal planar like this. SO3, sulfur group number 6, monovalent are 0 and nothing are there, no charge. 6 plus 0 by 2, that is also 3. 3 means sp2. So, for charged molecules, for uncharged molecules, equally you can go through in a perfect way with less time of utilization. Probably, I can say maximum will be 7 to 8 seconds. Within 7 to 8 seconds, you can develop majorly 5 important characteristics, including charged molecules also. H2SO3. Sulfurous acid. H2SO4 is sulfuric acid. H2SO3 is a sulfurous acid. Sulfur group number 6, 6 plus 2, 8, 8 by 2, 4. 4 is sp3. You got 4. For this you got 4. 4 which means that sp3 you got. sp3 you got. Tetrahedral only. That is sp3. It is sp2 trigonal planar. sp2 is trigonal planar. It is also trigonal planar. For carbonate, there is a better question in the JEE. What is that? You know what? What is the exact bond order in the carbonate? Exact bond order between carbon and oxygen and carbonate ion. Carbonate is, for that question also your answer is from our discussion only. Hybridization geometry. Let us see this one. Carbon 1, 2, 3. Because trigonal planar I am writing. 3 oxygens. 1, 2, 3 oxygens. But 2 minus. 1 minus here, 1 minus here. And what about this one means? There is a double bond who? CO3 2 minus, because there is a 2 charges, 2 minus charge. You know what? For writing the CO, this is one of the structures of carbonate. Let us take this is oxygen A, it is oxygen B, it is oxygen C. In this structure, oxygen A has double bond. Remaining 2 oxygens is single bond. Now you have one more option. Why only A has double bond? B also can have double bond. Okay, you can write resonating form. That means you can keep this minus charge here. It will shift like as a O minus. Same, you can, why not C? Yes, you have the total 3 resonating structures. Out of 3 resonating structures, in one resonating form only, that is a double bond O. In the remaining 2 structures, single bond O, single bond O. Therefore, you have to take the bond order is like this. Bond order will be always like this. Sum of the bond orders in all the resonating structures by total number of resonating forms. In this structure, double bond O, that means 2 plus. In another resonating structure, that is single bond O. In the third structure also single bond O. 2 plus 1 by total resonating forms are 3. 4 by 3. 4 by 3 it will be 1.33. The bond order in carbonate is 1.33. Previous day question is arrange the bond order among CO, CO2, CO3 2 minus. I am writing the question. The question is, previous day question is decreasing order of bond order. Decreasing order of bond order amongst, these are the molecules. Amongst, let you take CO3 2 minus, carbon monoxide and CO2. And it's one of the excellent questions. It might be bond order, it might be bond energy, it might be bond length also, whatever it might be, question can be given. I will explain all the characteristics. Let's observe. CO3 2 minus, bond order. Okay, again I am writing, there are 3 molecules. The 3 molecules, number 1 it is CO3 2 minus. Another is carbon monoxide, another is CO2. See this one, CO3 2 minus, carbon, double bond O, single bond O minus, single bond O minus. Here is 2 plus 1 by total resonating forms. So 4 by 3, that is equal to 1.33 is the bond order. So this is the way to calculate bond order for carbonate based on a concept of resonance. But whereas for CO, there is a C triple bond O. Carbon monoxide, there is actually one is a dative bond from oxygen to carbon. It has a 1 lone pair, it has 1 lone pair. This is exact structure for carbon monoxide. So bond order is 3. 3.0 is the bond order. Whereas CO2 is the linear molecule, double bond O and double bond O. Which means that CO2 is a linear molecule. And bond order is 2. So the bond order is 2.0. This is 3.0. Therefore, the correct order automatically. Therefore, bond order decreasing order. Bond order decreasing order will be highest is CO, carbon monoxide, which is the 3.0, while carbon dioxide, which is CO2, is at 2.0, while carbonate CO3 2 minus, that is 1.33 only. It is bond order decreasing order. You know what? Bond order and bond energy same. Bond energy or bond order will be same, because when the bond order is increasing, bond energy is automatically obviously increases. But bond length is different. I mean reverse. So now if you are asking that bond length decreasing order is what? Bond length decreasing order is reverse you take. That means CO3 2 minus bond length is more. After that CO2. After that it is CO, carbon monoxide. This is the way we can give for the molecules, bond lengths, bond orders, bond energies also. So in this session, I explained how to develop geometry, hybridization, type, shape, along with that bond angles. Additionally, few more points I quoted. That is about the dipole moment of a molecule called mu, and about one more thing is about acidity, basicity. I mean like H3PO4 has how many protons will be releasable, which is called the basicity. One more interesting thing I explained about is called bond order and bond lengths also. Hope you followed the class, and this is good, and this is enough as of now the discussion. Thank you.